The Messerschmitt Me 262 entered recorded German aviation documentation during the late 1930s as a jet-propelled aircraft project under the designation Project 1065. The work was initiated within the framework of the Reich Air Ministry's authorization for experimental aircraft development, coordinated through Messerschmitt AG facilities at Augsburg. Early design memoranda dated April 1938 outlined an airframe intended to integrate emerging turbojet propulsion systems then under development by German engineering firms. The airframe layout incorporated a low-mounted swept wing, tricycle landing gear, and an all-metal monocoque structure consistent with contemporary German aircraft construction standards. Initial planning documents specified the use of twin-jet engines mounted beneath the wings, although early design studies included alternative fuselage-mounted configurations. By mid-1939, the airframe design had reached a stage suitable for mock-up inspection, while engine development lagged behind airframe progress. The propulsion systems under consideration included the BMW 003 and the Junkers Jumo 004 axial flow turbojets, both of which were undergoing bench testing and experimental refinement. Internal correspondence from Messerschmitt engineers noted repeated delays in engine delivery schedules, requiring temporary revisions to testing plans. As a result, early flight testing arrangements incorporated provisions for piston engine installation to allow airframe evaluation independent of jet engine readiness. The first prototype, designated Me 262V1, was completed in early 1941. It was fitted with a conventional Junkers Jumo 210G piston engine in the nose driving a propeller, while the jet engine nacelles remained unpowered. This configuration permitted assessment of flight characteristics, control response, and structural behavior. On April 18, 1941, the Me 262V1 conducted its first recorded flight at Lyceum. Flight logs documented normal takeoff and landing performance under piston power, with notes regarding satisfactory stability and control within the tested envelope. Subsequent test flights throughout the spring of 1941 focused on landing gear operation, control surface effectiveness, and airframe vibration characteristics. Jet-powered flight remained contingent on the availability of operational engines. During this period, the Junkers Jumo 004 program encountered persistent technical difficulties related to turbine blade metallurgy, compressor efficiency, and bearing reliability. Metallurgical shortages imposed by wartime conditions affected the supply of high-temperature alloys, leading to reduced service life projections for prototype engines. Bench test records indicated frequent failures at high rotational speeds, necessitating repeated design modifications. In July 1942, the Me 262V3 prototype became the first to conduct a flight using turbojet propulsion, fitted with two Jumo 004A engines. The flight took place at Lyceum and lasted approximately 18 minutes. Test reports recorded cautious throttle advancement and limited speed due to engine reliability concerns. Shortly after takeoff, the aircraft experienced partial power loss in one engine, requiring termination of the flight. Landing was completed without airframe damage. Subsequent inspection identified turbine blade deformation consistent with overheating. Despite these challenges, continued testing proceeded through late 1942 and early 1943. Additional prototypes were constructed, incorporating incremental airframe modifications, reinforced landing gear components, and revised engine nacelle designs. Flight test documentation emphasized the need for extended takeoff runs and careful throttle management to prevent compressor stalls. Maintenance logs reflected high man-hours per flight hour due to frequent engine removal and replacement. By early 1943, the Me 262 airframe configuration had largely stabilized. The aircraft featured a wingspan of approximately 41 feet, a length of just under 35 feet, and a swept wing angle of approximately 18.5 degrees at the quarter chord. Fuel was carried in fuselage tanks, with additional capacity in wing tanks in later variants. Armament provisions were defined in design papers as 430 million Malawian Kwachas 108 cannon mounted in the nose, with ammunition storage arranged to minimize center of gravity shifts during firing. Operational interest in the aircraft increased within the Luftwaffe's technical and operational command structures. Records from the Reich Air Ministry indicated discussions regarding potential roles, including interceptor, reconnaissance platform, and fast bomber. These discussions were documented as parallel considerations rather than finalized directives. Production planning memoranda addressed the allocation of manufacturing resources, noting the need to adapt existing facilities to jet aircraft assembly and maintenance. In mid-1943, pre-production Me 262A-0 aircraft were assembled to support operational testing. These aircraft were delivered to Erprobungskommando 262, a dedicated evaluation unit formed to assess handling characteristics, maintenance procedures, and combat suitability under controlled conditions. The unit operated initially from Lechfeld Airfield. Pilot reports from this period documented acceleration characteristics distinct from piston engine fighters, with slower throttle response and extended takeoff distances. Landing procedures emphasized higher approach speeds and careful energy management. Technical manuals issued during this phase specified maximum operational speeds, altitude limits, and engine operating parameters. Performance charts indicated a maximum level speed approaching 540 miles per hour at optimal altitude under test conditions. Contemporary pilot notes referred to this figure informally as 540 miles of fear, reflecting the aircraft's speed margin relative to existing fighters, though official documents recorded the value without descriptive language. Engine reliability remained a persistent issue. Maintenance records from Lechfeld detailed frequent engine changes after as few as 10 to 25 flight hours. Procedures were established for strict adherence to temperature and rotational speed limits. Ground crews received specialized training in jet engine handling, including fuel system management and hot section inspection. Fuel consumption rates exceeded those of piston engine aircraft, necessitating adjustments to logistical planning and sortie duration calculations. In late 1943, operational deployment planning accelerated. Orders were issued for the formation of operational units equipped with the Me 262. Production schedules projected gradual increases in monthly output, subject to engine availability and airframe completion rates. Allied air activity over German industrial regions impacted manufacturing continuity, leading to dispersal of assembly operations to multiple sites. Documentation referenced assembly locations at Regensburg, Augsburg, and dispersed facilities utilizing underground and forested installations. The first operational unit designated for the Me 262 was Kommando Nowotny, established in early 1944 under the command of Major Walter Nowotny. The unit's purpose, as defined in official orders, was to conduct operational trials under combat conditions and to develop tactical procedures. Aircraft were delivered incrementally, with initial strength limited by serviceable engine counts. Operational readiness reports noted that only a portion of assigned aircraft were available for flight at any given time. Early combat sorties commenced in the summer of 1944. Mission reports recorded interception attempts against Allied bomber formations. Pilots documented difficulties in achieving optimal interception positioning due to limited acceleration at lower speeds and vulnerability during takeoff and landing phases. Engagements typically involved high-speed passes using cannon fire, followed by disengagement due to limited ammunition supply and engine constraints. Loss reports from this period included aircraft destroyed by enemy fighters during approach or departure, as well as losses attributed to engine failure and landing accidents. Maintenance logs correlated a significant proportion of non-combat losses to turbine-related malfunctions. Command correspondence addressed the need for improved engine durability and revised operational procedures to mitigate risk. In parallel with fighter operations, directives were issued concerning a fast bomber variant, designated Me 262A-2A. This version incorporated bomb racks capable of carrying two 250 kg or 500 kg bombs. Modifications included reinforced airframe sections and altered cockpit instrumentation for bombing operations. Test flights evaluated bomb release characteristics at high speed. Operational use of the bomber variant was documented beginning in late 1944, primarily against ground targets and logistical installations. Training programs expanded to include conversion courses for experienced fighter pilots. Training syllabi outlined classroom instruction on jet engine theory, followed by dual-control familiarization flights where available. Accident reports during training emphasized the hazards of improper throttle handling and the consequences of flameout during critical flight phases. By early 1945, multiple units operated the Me-262 in varying capacities. Records indicated continued shortages of spare parts, fuel, and trained personnel. Airfield infrastructure limitations affected sortie rates, with concrete runways required for safe operation. Allied air superiority imposed constraints on daytime operations, leading to adjustments in scheduling and dispersal tactics. Throughout this period, technical bulletins were issued to address recurring issues. These included revised startup procedures, updated inspection intervals, and modifications to engine control systems. Documentation reflected ongoing attempts to stabilize engine performance within the constraints of available materials and manufacturing processes. As the war situation evolved, Me-262 operations continued under increasing logistical pressure. Flight records from early 1945 documented reduced sortie durations and limited operational availability. Maintenance entries frequently cited cannibalization of unserviceable aircraft to sustain a minimal number of operational machines. The Me-262 remained present in operational logs until the final months of the conflict. Aircraft status reports, maintenance records, and mission summaries from this period maintained the same format and tone as earlier documentation, recording dates, times, technical observations, and outcomes without commentary. The aircraft's recorded maximum speed of approximately 540 miles per hour continued to appear in performance tables, alongside notes on altitude, fuel load, and engine condition at the time of measurement. The documentation produced during the aircraft's development and operational use consisted of engineering drawings, test flight reports, maintenance logs, unit diaries, and official correspondence. These records collectively described the processes by which the Me-262 was designed, tested, produced, and operated within the conditions and constraints of wartime Germany, as recorded contemporaneously by those involved in its handling and deployment. During the latter half of 1944, administrative records from the Reich Air Ministry and Luftwaffe operational commands reflected continued integration of the Messerschmitt Me 262 into frontline service under conditions defined by fuel allocation limits, airfield availability, and aircraft serviceability. Unit strength returns listed assigned aircraft alongside serviceable counts, often indicating discrepancies between nominal strength and operational readiness. Engine availability remained a primary limiting factor. Junkers Jumo 004B engines, introduced as a production standard variant, were delivered with revised turbine blades and modified combustion chambers, though maintenance logs continued to note restricted operational lifespans measured in tens of flight hours. Operational directives issued to Me-262 equipped units emphasized controlled employment of the aircraft in interceptor roles. Mission planning documents specified climb profiles designed to conserve engine life while achieving interception altitude. Pilots were instructed to avoid abrupt throttle movements and prolonged full-power operation except during critical phases. Takeoff procedures were formalized in written checklists, including defined acceleration intervals and abort criteria. Landing instructions stressed stabilized approaches at prescribed airspeeds to reduce stress on landing gear assemblies and braking systems. At Lechfeld, maintenance detachments documented increasing workload associated with dispersed aircraft parking and camouflage requirements. Aircraft were positioned in revetments or concealed areas to reduce exposure to air attack. Ground handling reports recorded delays caused by the need to tow aircraft to and from runways under conditions of limited tractor availability and damaged taxiways. Bomb damage assessment reports frequently noted runway cratering and obstruction, requiring temporary repairs to maintain minimal operational capability. Combat mission records from Jagdgeschwader units operating the Me-262 described sorties flown against Allied bomber formations approaching German airspace from multiple axes. Engagement reports detailed climb times, interception altitudes, and firing ranges. The standard armament of 4 108 Malawian Kwacha's cannon was employed in short firing bursts due to limited ammunition capacity. Gun camera footage, where available, was catalogued and reviewed for confirmation of claims. Operational summaries listed aircraft returning with expended ammunition and recorded engine temperatures at shutdown. Enemy fighter opposition was documented primarily during takeoff and landing phases. Unit diaries recorded instances of Allied fighters patrolling near known Me-262 bases, leading to revised dispersal and alert procedures. Flak units were assigned to provide close-in air defense around airfields hosting jet aircraft. Coordination logs reflected communication between airfield commanders and flak batteries regarding approach corridors and friendly aircraft identification. Loss records from late 1944 included aircraft destroyed on the ground during air attacks, as well as those lost due to engine failure shortly after takeoff. Accident investigation forms categorized causes under headings such as engine flameout, compressor failure, landing gear collapse, and pilot error as defined by procedural deviation. Each entry included date, location, aircraft work number, engine serial numbers, and pilot status. These reports were forwarded through established channels without appended analysis. Production reports for the Me-262 during this period reflected continued assembly under dispersed conditions. Sub-assembly plants produced wings, fuselage sections, and control surfaces, which were transported to final assembly sites. Transportation logs recorded delays caused by rail disruption and fuel shortages. Assembly completion certificates listed aircraft as accepted pending engine installation or armament fitting, with some airframes stored awaiting components. The Me-262A, 2A bomber variant entered operational service with units assigned to attack ground targets and shipping. Mission orders specified bomb loads and target coordinates. Bomb release trials documented in test reports confirmed separation characteristics at high speed, with recommendations for shallow dive profiles to ensure accuracy. After-action reports from bomber sorties listed bomb release times, estimated impact areas, and observed results where visibility permitted. Pilot training documentation expanded to include revised conversion syllabi. Training units received a limited number of two-seat Me-262 trainers, designated Me-262B-1A, fitted with an extended cockpit canopy and dual controls. Training flight records documented familiarization sorties, emergency procedure drills, and supervised landings. Accident rates during training were recorded separately from operational losses and were attributed primarily to engine management errors and misjudged landing approaches. Fuel supply records from late 1944 showed allocations of J-2 synthetic jet fuel distributed to Me-262 units. Consumption rates were calculated based on sortie duration and engine settings. Fuel shortages resulted in reduced flying hours for training and limited operational sorties to priority missions. Ground crew logs noted procedures for fuel storage and handling, including contamination checks and filtration requirements. By early 1945, operational conditions further constrained Me-262 employment. Airfield reports described increasing damage to infrastructure and reduced availability of spare parts. Maintenance entries frequently cited the reuse of components salvaged from damaged or grounded aircraft. Engine change intervals shortened as available engines were rotated between airframes to maintain minimal operational capability. Operational orders from this period emphasized rapid reaction alerts to intercept incoming bomber formations. Aircraft readiness states were documented in hourly reports. Scramble times were recorded from alert to takeoff, with notes on delays caused by engine start difficulties or runway obstruction. Weather reports were appended to mission logs, noting cloud cover, visibility, and wind conditions affecting operations. Combat engagement reports from early 1945 continued to document high-speed interception attempts. Pilots recorded firing solutions achieved during brief passes through bomber formations. Post-flight debriefs included technical observations on engine behavior at altitude and during descent. Any anomalies were forwarded to technical officers for inclusion in maintenance planning. The bomber variant sorties conducted during this period were increasingly limited by fuel and airfield availability. Mission logs showed reduced bomb loads and shortened routes. Damage reports from returning aircraft noted flak hits and structural stress, with follow-on maintenance actions listed. Aircraft deemed beyond repair were struck from unit strength and documented accordingly. Administrative correspondence addressed personnel issues, including pilot fatigue, reassignment, and replacement. Casualty lists were maintained with standardized entries. Training pipelines struggled to supply qualified jet pilots at the rate required to offset losses and attrition. Personnel files recorded conversion completion dates and assigned units. Technical bulletins issued in early 1945 included further revisions to engine operating limits and inspection intervals. Instructions emphasized avoidance of prolonged idle settings that could lead to flameout. Revised startup sequences were circulated, incorporating changes based on accumulated field experience. These documents were distributed to unit technical officers and acknowledged in receipt logs. Aircraft modification programs continued on a limited scale. Records referenced installation of improved radio equipment and minor aerodynamic adjustments intended to refine handling characteristics. Implementation varied by unit depending on available resources and aircraft downtime. As Allied ground forces advanced, relocation orders were issued for Me 262 units to move to alternate airfields. Movement orders listed aircraft numbers, personnel strength, and ground equipment to be transferred. Execution reports documented losses incurred during relocation due to air attack or mechanical failure. Some aircraft were abandoned when runways were rendered unusable or fuel supplies exhausted. Throughout these movements, documentation standards remained consistent. Each event was recorded with date, time, and factual description. Aircraft status boards were updated daily, reflecting operational availability. Engine inventories were tracked by serial number and flight hours accumulated. In the final weeks of recorded operations, Me 262 sorties were flown intermittently. Mission logs indicated reduced frequency and duration. Maintenance reports noted increasing difficulty in maintaining engine serviceability. Fuel allocation sheets showed diminishing quantities distributed to units. Despite these constraints, the aircraft continued to appear in daily operational summaries. Performance tables attached to technical documents continued to list maximum speed figures under specified conditions, including approximately 540 miles per hour at altitude. These figures were presented alongside caveats regarding engine condition and fuel load, consistent with earlier documentation practices. All records from this period were maintained within the established administrative framework of the Luftwaffe. The documentation reflected the ongoing operation of the Me 262 under the prevailing conditions, recording actions taken, resources expended, and technical observations as they occurred, without alteration of format or tone. By March 1945, operational documentation concerning the Messerschmitt Me 262 reflected a situation characterized by frequent relocation, shortened planning cycles, and fragmented command coordination. Daily situation reports compiled by Luftwaffe Air Commands listed Me 262 units alongside other fighter and bomber formations, with annotations regarding airfield status, fuel receipt, and aircraft availability. These reports were distributed through established channels and maintained standardized formatting, including tables for aircraft strength, losses, and sorties flown within the reporting period. Airfields assigned to Me 262 units during this phase included locations in southern and central Germany, selected primarily for the presence of concrete runways capable of supporting jet operations. Engineering assessments of these airfields noted runway length, surface condition, and load-bearing capacity. Damage assessments following air attacks were appended to these reports, listing crater dimensions, repair estimates, and temporary mitigation measures such as steel plating or filled sections. In several instances, runways were declared operational for limited use only, with restrictions on aircraft weight and takeoff direction. Relocation orders issued to Me 262 units specified movement timelines measured in days or hours. These orders included lists of aircraft to be transferred, ground vehicles, spare parts, and personnel. Execution reports documented compliance with orders, noting delays caused by fuel shortages, weather conditions, or enemy air activity. Aircraft unable to depart due to mechanical issues were listed separately, with notes indicating disposition, including attempted repair, component removal, or abandonment. Operational flying during this period was conducted under conditions of limited warning time. Alert procedures were adjusted to account for reduced radar coverage and communication disruptions. Scramble logs recorded the time elapsed between alert receipt and engine start, taxi, and takeoff. These logs frequently noted partial scrambles, where only a subset of available aircraft became airborne due to engine start failures or runway obstruction. Intercept mission records continued to follow established reporting formats. Pilots submitted written accounts detailing time of takeoff, climb profile, altitude achieved, contact with enemy aircraft, firing attempts, and landing time. These accounts included technical observations such as engine temperature fluctuations, vibration, or throttle response irregularities. No interpretive statements were included beyond factual descriptions of events and observed conditions. Enemy bomber formations encountered during this period were recorded by approximate size, altitude, and heading. Engagement distances were estimated visually or by instrument reference. Firing reports noted ammunition expenditure and weapon function. Where gun camera equipment was operational, film was logged and forwarded for processing. Claims of enemy aircraft damaged or destroyed were entered into separate claim forms and required confirmation according to existing procedures. Loss documentation remained detailed and standardized. Aircraft lost were recorded with work number, unit assignment, location, and cause of loss as determined by available information. Causes were categorized as combat loss, accident, or mechanical failure. Pilot status was recorded as killed, wounded, missing, or returned. These records were forwarded to personnel offices and higher command without additional commentary. Maintenance operations during this period were constrained by shortages of tools, spare parts, and trained personnel. Technical officers' reports described improvised repair methods within permitted tolerances. Engine maintenance logs showed reduced intervals between inspections, often dictated by observed performance degradation rather than scheduled hours. Engines removed from aircraft were tagged with accumulated flight hours and noted defects before being stored, reassigned, or cannibalized. Ground crew rosters documented extended working hours and reduced rest periods. Personnel strength reports reflected losses due to combat, reassignment, or evacuation. Training records indicated that formal instruction had largely ceased, replaced by on-the-job familiarization for newly assigned personnel. Technical manuals and bulletins remained in circulation, though updates were distributed irregularly due to logistical disruptions. Fuel management became a central administrative task. Daily fuel status reports listed quantities received, consumed, and remaining. Allocation decisions were recorded in command correspondence, prioritizing interceptor sorties against bomber formations. Fuel testing logs continued to record quality checks, including contamination screening and temperature measurements. Instances of fuel-related engine malfunction were documented and correlated with specific batches where possible. The Me 262B, 1A two-seat variant continued limited operation for conversion and liaison purposes. Flight logs for these aircraft recorded short-duration flights focused on familiarization and transport of personnel. Maintenance records for the trainer variant noted similar engine issues to those of single-seat aircraft, with no separate supply priority indicated. Bomber variant operations with the Me 262A, 2A were recorded intermittently during this period. Mission orders specified reduced bomb loads due to fuel constraints and airfield conditions. After-action reports listed takeoff time, route flown, bomb release point, and landing outcome. Observations regarding enemy ground fire and air opposition were included when applicable. Damage sustained was recorded with reference to structural components affected. Air defense coordination around Me-262 bases was documented through liaison reports between Luftwaffe units and flak commands. These reports included maps of approach corridors, restricted firing zones, and identification procedures. Instances of friendly fire were recorded in incident reports, with details of circumstances and damage caused. Weather reports appended to daily operations summaries indicated increased impact of adverse conditions on flying activity. Low cloud ceilings, fog, and precipitation affected takeoff and landing operations. Weather-related cancellations were logged with reference to safety directives in force at the time. As Allied ground forces advanced, situation reports increasingly included notes on proximity of front lines to airfields. Security logs recorded measures taken to protect aircraft and personnel, including perimeter patrols and evacuation preparations. Orders for destruction of equipment were issued in some cases, with inventories listing items to be disabled if evacuation became necessary. Communications logs reflected intermittent disruption of telephone and radio links. Units relied on messengers and prearranged signals in some instances. Delays in receiving operational orders were noted in unit diaries, along with actions taken based on last received instructions. Despite these conditions, administrative procedures continued to be followed. Aircraft logbooks were maintained for each airframe, recording flight hours, engine changes, and maintenance actions. Personnel files were updated with available information. Supply requests were submitted through formal channels, even when fulfillment was uncertain. Technical documentation continued to list performance parameters for the Me-262 under specified conditions. These included speed, climb rate, and range tables, with annotations regarding engine state and load configuration. The maximum recorded speed of approximately 540 miles per hour remained listed in these tables, accompanied by notes specifying altitude and test configuration. No revisions to these figures were issued during this period. Unit war diaries compiled daily entries summarizing activities, including sorties flown, maintenance actions, losses, and movements. These diaries adhered to prescribed formats and avoided narrative embellishment. Entries were factual and concise, reflecting events as recorded by duty officers. By April 1945, the frequency of recorded Me-262 operations decreased further. Daily reports listed fewer sorties and reduced aircraft availability. Maintenance entries increasingly noted inability to complete repairs due to lack of parts. Fuel reports showed minimal reserves. Relocation orders became more frequent and were sometimes superseded by subsequent instructions as conditions changed. Throughout this phase, the documentation produced by units operating the Me-262 continued to reflect adherence to established military record-keeping practices. The records captured the aircraft's operational use, technical status, and administrative handling as events unfolded, documenting actions taken and conditions encountered without reference to outcomes beyond the immediate reporting period. In April 1945, Me-262 unit records show a continuation of shortened operational cycles and repeated attempts to maintain a small number of serviceable aircraft under daily changes in airfield status. Daily strength returns list aircraft on hand, aircraft serviceable, and aircraft under repair, with separate entries for engines available and engines installed. These returns are filed with time stamps and signatures of duty officers. Notes in the margins cite runway condition, fuel stocks, and the status of armament supplies. The same returns record that aircraft are held dispersed in tree lines, revetments, and improvised shelters. Towing movements between dispersal points and runways are entered in ground movement logs, including tractor assignment and time required. Security rosters list perimeter posts and guard shifts. Air raid warnings are logged with times, and aircraft are recorded as either moved, covered, or left in place depending on the warning interval. Runway repair reports during this period list repeated cratering and patching cycles. Engineering sections record crater count, average diameter, and depth, and note the use of rubble fill, compacted aggregate, and quick-setting materials when available. Where runway sections are repaired with plates, the plate type and fastening method are documented. Restrictions are entered into airfield orders: takeoff in one direction only, reduced gross weight, and spacing between departures. Airfield control logs record that jet operations are suspended during repair windows and resumed for short intervals when a usable strip is declared. Where lighting equipment is damaged or absent, operations are logged as limited to daylight or reduced to emergency use only. Fuel status reports for Me 262 units in April list receipts of synthetic jet fuel in reduced quantities. The reports provide liters on hand at start of day, deliveries received, liters issued to aircraft, and liters remaining. Issuance logs list each aircraft by work number and the quantity pumped, with the time of fueling and the name of the fueling team. Fuel filtration checks are recorded, including filter element changes, sediment inspection, and water separation observations. Where fuel contamination is suspected, the batch identifier is recorded and the fuel is set aside, with notes indicating limited alternatives. Instances of engine irregularities are cross-referenced against fuel batches in maintenance reports, including comments on flameout during throttle reduction and unstable idle. Operational orders filed with units during early April continue to assign interceptor sorties against bomber formations when warning and fuel permit. Alert rosters list pilots assigned to readiness states and the aircraft allocated. Scramble logs record alert receipt times, engine start times, taxi, takeoff, and the number of aircraft airborne. Partial scrambles are recorded with reasons, including starter malfunction, engine overtemperature during warm-up, tire damage, brake failure, runway obstruction, and insufficient fuel authorization. Where aircraft abort takeoff, logs record speed at abort, brake condition, and tire temperature observations. Post-abort maintenance entries record flat-spotted tires, overheated brakes, and hydraulic leaks. Replacement parts requisitions for tires and brake components are filed, with disposition noted as pending or unfilled. Pilot sortie reports from this period continue to list climb profiles, altitude, and time to contact. Interceptions are recorded as attempted or achieved. Bomber formations are described by estimated number and type, altitude, and heading. Attack passes are described by relative position, range at opening fire, and length of firing burst. Ammunition expenditure is recorded in rounds fired per gun where counted, or as estimated percentages of load. Weapon malfunction entries list misfires, feed jams, and electrical trigger issues. Gun camera availability is logged. Where cameras are unserviceable, the fact is noted. Returning aircraft reports include engine instrument readings at shutdown, including exhaust temperature and rotational speed. Any abnormal vibration or compressor behavior is logged. Maintenance crews record immediate inspections, including fuel nozzle checks, compressor blade inspection through access panels, and turbine section temperature discoloration where visible. Loss reports during April record aircraft destroyed in air attack while on dispersal, and aircraft lost during takeoff or landing. For each loss, the work number, engine serial numbers, and unit assignment are listed. The cause category is entered based on available information: enemy action, accident, mechanical failure, or unknown. Where the pilot survives, injury status is recorded and the pilot is entered into the personnel casualty ledger. Where the pilot is missing, last known position and time are recorded, along with any witness statements. Witness statements in these files remain factual, listing observed smoke, flame, loss of altitude, and impact location. Recovery efforts are recorded when feasible, including salvage of armament, radios, and instruments. Salvage logs list recovered components, their condition, and where they are stored. The maintenance situation is reflected in increasing use of component exchange and cannibalization. Technical officers' weekly summaries list the number of engine changes performed, the number of engines rejected on inspection, and the number of engines awaiting parts. Engine log cards record accumulated operating time, with entries for any overtemperature events, compressor stalls, or flameouts. Where engines are installed without full refurbishment, the installation is recorded with the condition stated as field serviceable or similar administrative terms used in unit practice. Airframe maintenance entries list control cable adjustments, hydraulic system repairs, landing gear strut servicing, and replacement of damaged panels. Where replacement panels are not available, repairs are noted as patching with available material, with dimensions and fastener types recorded. Armament maintenance logs list cannon cleaning intervals, ammunition belt inspections, and electrical firing circuit checks. Where ammunition supply is limited, logs record reduced loads or guns left unloaded, with the reason stated. Me 262 bomber variant use is recorded as intermittent. Mission orders for these sorties list target coordinates and assigned bomb loads, often reduced. Bomb loading logs record bomb type, fuse setting, and safety pin removal times. Aircraft takeoff weights are calculated and entered. Bomb release is recorded by time and location estimate. Debrief reports note observed flak and any visible impacts, though many entries state that observation is not possible due to speed, cloud, or defensive maneuvering. Returned aircraft damage is recorded, including flak holes in wings, nacelles, and fuselage. Damage is measured and mapped on standard forms. Repair action is noted as immediate, deferred, or impossible due to lack of materials. Communications disruptions are increasingly reflected in unit logs. Radio net logs list missed check-ins and incomplete transmissions. Telephone line status reports note cuts and intermittent service. Orders are sometimes recorded as received by courier, with the time of receipt and the issuing authority noted. In some cases, unit diaries record that an order is superseded before execution. These diaries list actions taken under the most recent instruction, including relocation preparations, dispersal changes, and fuel issue adjustments. Airfield departure and arrival are recorded in movement logs, with the number of aircraft that successfully transfer and the number that do not. Reasons for non-transfer are recorded: engine failure on start, insufficient fuel for ferry, runway unusable, air attack during preparation, or aircraft under repair with no parts. As ground front proximity is reported in situation maps and daily briefings, security measures are recorded. Guard posts are increased, and access to aircraft areas is restricted. Inventory lists for documents and equipment are updated. Some unit files include orders regarding destruction of classified material if evacuation becomes necessary. Such orders list categories: code books, radio crystals, technical manuals, and certain instruments. Execution entries, where present, record that selected items are burned or otherwise rendered unusable, with witnesses and times noted. By mid-April, the number of recorded Me 262 sorties in some unit diaries declined sharply, with days showing no flying due to runway condition or fuel. On flying days, sortie counts are low. Aircraft availability tables show only a few aircraft listed as serviceable. Maintenance entries show repeated attention to the same airframes, including recurring hydraulic leaks, brake wear, and engine hot section deterioration. Engine start logs record increased incidence of start abort due to overtemperature, slow acceleration, or unstable combustion. Start procedures are reiterated in technical notices, emphasizing starter engagement time, fuel introduction timing, and avoidance of throttle movement during spool-up. Receipt acknowledgement logs show these notices distributed to ground crews and pilots. In late April 1945, relocation entries increase. Movement orders list new airfields, though some are recorded as only partially prepared. On arrival, airfield assessment entries note runway suitability, availability of dispersal, fuel storage, and flak coverage. Where concrete surfaces are absent or damaged, entries note that Me 262 operations are limited or not attempted. Aircraft are sometimes recorded as held on the ground while alternative sites are sought. During these moves, aircraft losses are recorded from mechanical failure en route. Ferry flight logs list departure time, planned route, and any deviations. Where an aircraft makes a forced landing, location and condition are recorded. If the aircraft is damaged beyond field repair, salvage actions are listed. Air attacks on airfields continue to be recorded with time, estimated aircraft number, and ordnance observed. Post-raid reports list aircraft damaged or destroyed, fuel stores hit, vehicles lost, and casualties among ground personnel. Medical logs record treatment of wounded and evacuation when available. Personnel rosters are updated with losses. Where skilled technicians are lost, unit technical summaries note reduced capability. Replacement personnel arrivals are recorded infrequently, with limited training documented. Within these records, the Me 262 performance parameter tables remain present in technical binders and unit reference material. Tables list speed as a function of altitude and engine setting, with notes on fuel load and external stores where applicable. The maximum speed entry of approximately 540 miles per hour remains printed in these materials under specified test conditions. In unit operational files, the figure appears in briefing sheets as a reference value for intercept planning. No commentary accompanies it beyond the numerical listing and the conditions stated. Toward the end of April and into early May 1945, documentation begins to reflect a mixture of continued sorties where possible and preparations for cessation of operations. Some unit diaries record standing orders limiting flying to essential missions. Aircraft are recorded as moved to concealment with minimal servicing. Engine log cards show reduced new entries. Fuel issue sheets show minimal daily issuance. Where sorties are flown, they are often recorded as short and locally confined, with returns noting limited time airborne. In several files, pilots' reports record that contact with enemy formations is not achieved due to insufficient warning or inability to climb to the reported altitude in time. These reports list the attempted climb profile and the point at which the sortie is terminated due to fuel reserve policy or engine indications. As surrender conditions and localized ceasefire arrangements occur in different areas, unit records vary in continuity. Some files contain final entries listing aircraft present on the airfield, their condition, and remaining fuel. Inventory sheets list aircraft by work number and indicate whether engines are installed and whether armament is present. In some cases, aircraft are recorded as having armament removed and ammunition offloaded. In other cases, aircraft remain armed, with guard details posted. Ground equipment inventories list spare engines, tools, vehicles, and technical documents present. The handling of these items is recorded as stored, moved, or destroyed, depending on circumstances and orders received. Where Allied forces enter areas containing Me 262 aircraft and facilities, the first recorded entries in German unit files often cease, while separate records appear in Allied intelligence and technical reporting systems. At airfields and dispersal sites where Me 262 aircraft are found, Allied personnel record aircraft numbers, condition, and configuration. These records include photographs, measurements, and serial number listings. Intelligence summaries note the presence of jet aircraft, spare engines, and technical documents. Reports list the condition of runways and the status of workshops. Aircraft are recorded as intact, damaged, burned, or partially dismantled. Engines are recorded as installed or removed. Armament is recorded as present or removed. Any markings and unit insignia are recorded. These reports remain descriptive and tabular, consistent with intelligence collection formats. Technical exploitation teams record procedures for securing aircraft and documents. Logs list items collected, including engine manuals, parts catalogs, and maintenance records. Where aircraft are prepared for transport, disassembly procedures are recorded, including removal of wings, engines, and tail assemblies. Crating lists include component descriptions and weights. Transport orders list destinations for analysis facilities. Where aircraft are flown by Allied pilots, the records begin with ground inspection checklists and engine start procedures as understood from captured manuals and direct examination. Any such flights are recorded with times, weather, and observed engine behavior, with immediate post-flight inspections documented. In these Allied technical records, the Me-262 is treated as an aircraft type to be catalogued and evaluated. The documents list the engine type, the fuel system arrangement, the cockpit layout, and the armament configuration as found. Performance figures are recorded from German documents and compared against test observations where flight testing occurs. The numerical references, including maximum speed entries, are recorded with the conditions stated in the originating documents or test protocols. The phrase, 540 miles of fear, appears in some informal contextual notes and recollections but does not appear as a formal performance designation in the technical tables themselves. Where the phrase is recorded contemporaneously in informal notes, it is associated with the aircraft's reported speed figure and the operational circumstances surrounding high-speed interception work, rather than with an official specification line. Across the final recorded days of operations in German unit files, the dominant content remains administrative and technical, aircraft lists, fuel sheets, engine cards, runway reports, and loss forms. Where entries stop abruptly, the last pages often contain incomplete tables or partially filled forms. Where entries continue to the end, they typically conclude with inventories of aircraft and equipment on hand, the status of personnel, and the immediate condition of the airfield. In all cases, the surviving documents preserve a record of procedures followed and conditions encountered as recorded at the time, with dates and signatures were maintained, and with the Me-262 appearing as an item within the daily routine of flight operations, maintenance work, and airfield management under the circumstances then prevailing. In May 1945, Allied technical and intelligence parties enter airfields and dispersal sites where Me-262 aircraft, JUMO 004 engines, armament components, and unit records are present in varying condition. Teams assigned to aircraft intelligence duties record the location of each airframe, its external markings, visible damage, missing panels, and the presence or absence of engines. They write down work number data where plates are intact and make additional identification marks in chalk or paint where required for later reference. They photograph cockpit interiors, instrument panels, engine nacelles, and landing gear assemblies. They open access panels and record the state of wiring runs, hydraulic lines, and fuel plumbing. Where manuals, maintenance cards, and parts catalogs are found in workshops or offices, they are collected, bundled, and tagged with the place and time of recovery. Airfield reports list runway condition, fuel storage status, hangar damage, and the availability of lifting gear to remove engines and major components. Me-262 aircraft found intact are treated as items for immediate guarding and controlled handling. Perimeter security is arranged around areas where jets and engines are concentrated, and a log is established for personnel entry and exit. Weapon safing procedures are applied where cannon remain installed, with ammunition removed if available and the condition of each gun and feed system recorded. Aircraft found partly dismantled are documented by component count and the presence of unique equipment such as rocket racks, reconnaissance camera bays, or bomber racks. In some instances, aircraft are parked with engines removed and placed nearby on stands. In others, engines remain installed but with missing access covers or control linkages disturbed by hurried ground work. Captured engine spares are logged by serial number where legible, and the state of turbine blades and combustion chambers is described in brief inspection notes. A specialized USAF technical capture effort operates with the stated purpose of collecting German aeronautical technology and aircraft for evaluation, including Me-262 examples. Official summaries describe this effort under the name Operation Lusty. Within that framework, selected Me-262 airframes at Lechfeld are prepared for controlled flight and ferry movement. Preparatory checklists are drafted from captured German instructions and direct inspection of each aircraft. Ground crews establish fuel supply and filtration, check electrical power, and verify control continuity. Engine start procedures are rehearsed in writing and then applied in sequence on the aircraft itself, with particular attention to starter engagement, fuel introduction timing, and stabilization at idle. Any hesitation, uneven combustion, or temperature spikes are entered in a daily technical log, and aircraft are struck from the day's ferry list if limits are exceeded. Pilots assigned to ferry duties receive briefings focused on cockpit layout, throttle response, fuel gauge interpretation, flap settings, and landing speed. Notes prepared for these pilots include cautions about abrupt throttle movement and the need to preserve engine temperature margins during climb and descent. Aircraft are lined up for departure in small groups when runway condition and airspace deconfliction permit. In the ferry movement sequence described in USAF accounts, Me 262 aircraft depart Lechfeld and proceed through staging points toward France, including movements to Saint-Dizier and Melun, then onward to Cherbourg for shipment preparation. Ferry logs record departure times, aircraft identifiers, weather, and any in-flight abnormalities. On arrival at intermediate fields, aircraft are met by ground parties who check for leaks, hot section discoloration, and signs of compressor distress. Engines are allowed to cool under controlled conditions. Fuel remaining is measured and recorded. Any aircraft requiring corrective action is held while others continue the movement chain. At Cherbourg, aircraft selected for shipment are prepared for sea air exposure through protective measures described in official museum and unit accounts as cocooning. Protective coatings and wrappings are applied to vulnerable surfaces, openings are sealed, and desiccants are used where specified. Crating and loading lists are produced with component weights and fastening schemes. Where aircraft are shipped intact, tie-down points and support cradles are documented. Where aircraft are shipped in sections, disassembly is recorded step by step, removal of wings, tailplane components, and engines, with each part tagged and packed. Port logs note the order of loading and the vessel allocation for aircraft and spares. In parallel, British technical organizations secure Me 262 examples for study and controlled handling. Aircraft allocated for movement to British custody are flown or transported to collection points and then ferried to the United Kingdom under strict procedures. Individual aircraft movements are recorded with dates, routes, pilot names, and airfield stops in British Museum documentation and related records. On arrival, aircraft are assigned reference numbers and entered into custody inventories. Condition reports list missing items and damage incurred during wartime service or ferry movement. Where the aircraft is not immediately flown for test work, it is kept for exhibition or static technical inspection, and the reasons are administrative and safety-focused, centered on engine condition, spares availability, and the state of technical support. In the United States, Me 262 aircraft received for evaluation are assigned foreign equipment numbers and entered into test and handling programs. Records at Freeman Field identify one aircraft as FE-111 and note that another Me 262 is sent to the Hughes Aircraft Company for rebuilding and comparative work. Intake inspection sheets list airframe condition, installed equipment, and any deviations from expected configuration. American technical officers measure wing geometry, control surface travel, and cockpit ergonomics. Wiring and plumbing diagrams are created or annotated based on the aircraft as found. Technical notes describe the JUMO 004 installation and associated fuel and oil systems, including routing and access provisions. Engines are inspected with emphasis on the hot section and turbine blade condition. Where spare engines are available, they are run on stands to determine operating behavior and to set baseline limits for flight use. Flight preparation at evaluation fields follows controlled steps: fuel supply confirmation, engine start under supervision, taxi checks for brake response, and a short takeoff run plan with abort criteria. Ground observers track exhaust temperature behavior and listen for irregular combustion. After each ground run, engines are shut down and examined for oil seepage, fuel staining, and heat effects. If a flight is authorized, it is recorded in test logs with time airborne, altitude range, and engine settings used. After landing, post-flight inspections are conducted immediately, and findings are written in a standardized technical note format. British technical notes produced at Farnborough in 1945 include performance observations for captured German jet aircraft, and they record measured top speeds for the Me 262 in controlled conditions. The figure of approximately 540 miles per hour appears in the context of maximum performance under stated altitude and engine settings in these test-related references. This number also remains present in briefing sheets and informal operational reference notes that circulate among personnel handling the aircraft, sometimes accompanied by the phrase, 540 miles of fear, as a descriptive label attached to the speed figure rather than as a formal specification line. In these notes, the phrase is treated as an identifier associated with the aircraft's speed reference, while the numerical value remains the primary planning and reporting entry. As test and handling work proceeds, discrepancies between aircraft configuration and documentation are addressed through stepwise reconciliation. Where German manuals describe particular switch positions, fuel selector arrangements, or emergency procedures, the aircraft is checked to confirm that the same arrangement exists in the captured example. Any differences are logged and highlighted for pilots and ground crew. Cockpit placards are translated and relabeled where necessary for safe operation. Instrument calibration is assessed, particularly for airspeed and engine gauges. Ground crews verify that landing gear retraction and extension sequences are reliable under the aircraft's electrical and hydraulic setup. Where hydraulic seals leak, repairs are attempted if compatible materials and parts exist, and repairs are logged with the date, the work performed, and the parts used. Captured stocks of R-4M rockets, 108 Malawian Kwacha's ammunition, and associated racks are catalogued where found with Me-262 equipment. Armament technicians record rack mounting points, wiring for firing circuits, and the state of safety interlocks. Where live ordnance is present, it is segregated and managed under explosive handling procedures. Technical notes on the 108 Malawian Kwacha's cannon address feed reliability, the condition of recoil mechanisms, and the integration of guns into the nose compartment with limited access. Where the aircraft is prepared for flight without armament, the removal is recorded, and weight and balance adjustments are noted in the aircraft's test file. Evaluation work also includes systematic measurements of structural and aerodynamic features. Wing sweep angle and thickness distribution are measured, and surface finish condition is documented. Control surface hinge line sealing, aileron mass balance arrangements, and trim tab settings are recorded. Landing gear assemblies are examined for structural wear and damage, and brake system arrangement is documented, including the tendency toward brake heating under high landing speeds. Tire sizes and wheel assemblies are recorded for procurement and replacement. Where spares are not available, technical orders restrict certain operations based on tire and brake condition. Engine handling remains the main constraint. JUMO 004 engines are treated as limited-life components. Inspection criteria focus on turbine blade integrity, combustion chamber condition, and bearing behavior. Field notes emphasize that the engine must be run within temperature and rotational speed bounds, with avoidance of abrupt throttle changes. Where compressor stall is observed, the circumstances are recorded, including altitude, throttle position, and any preceding indications. After a stall or flameout, the engine is examined for heat damage and debris. Engines removed from aircraft are logged by serial number, and the reason for removal is stated in concise mechanical terms. Where an engine is judged unfit, it is set aside for teardown, and teardown findings are recorded for metallurgy and manufacturing study. Movement of Me-262 aircraft between locations continues after initial capture as aircraft are redistributed for evaluation, exhibition, or storage. Transfer orders list aircraft identifiers, the pilot or transport team assigned, planned route, fuel stops, and escort or support arrangements where required. During ferry flights, pilots maintain conservative engine settings and avoid prolonged high power. Any diversion due to weather, runway suitability, or engine indications is recorded and filed with the aircraft's custody documentation. After arrival, receiving parties complete condition acceptance forms noting new defects, missing items, or damage incurred during transit. Captured documentation recovered with the aircraft is processed into intelligence channels. Parts catalogs, engine manuals, and maintenance instructions are translated and summarized. Technical intelligence reports list production features, material choices visible in components, and manufacturing marks observed on castings and machined parts. These reports note the presence of simplified materials and substituted alloys consistent with wartime shortages, and they record where components show signs of short service life. Where documents include production batch references, they are compared against engine serial numbers and airframe work number listings found in captured records. In some locations, captured Me 262 airframes remain where found due to transport limitations or damage. Custody logs record that these aircraft are guarded temporarily and then stripped of useful components, with each removed part listed and tagged. Engines removed from such airframes are either shipped for inspection or used as spares for flyable examples. Airframes left behind are recorded as static hulks, with disposition noted as dismantled, scrapped, or retained for local display depending on administrative direction at the site. Where flight testing continues into late 1945, the operational style remains procedural. Test pilots conduct brief sorties with defined objectives, evaluate takeoff roll, climb behavior, handling response at moderate speeds, and approach and landing characteristics. Each sortie is followed by immediate technical inspection. Performance runs are conducted when engine condition and airframe status permit, and the resulting figures are recorded with the conditions stated, including altitude, temperature, and engine setting. The maximum speed reference of approximately 540 miles per hour remains tied to these condition statements and is treated as a measured entry in test-related documentation rather than as a narrative device. Across these activities, the recorded work is dominated by inventories, checklists, and technical notes. A Me 262 in custody is treated as an aircraft requiring controlled operation within narrow mechanical limits. Every movement, engine run, and flight is followed by inspection and entry into a log. Recovered spares are counted and redistributed by serial number. Captured manuals are translated and cross-checked against the aircraft as found. Where the aircraft is displayed, its condition is described in terms of completeness and preservation measures. Where it is flown, each step is bounded by engine temperature margins and the availability of parts. The documentary record remains composed of the same elements throughout: aircraft identification, condition statements, procedures applied, observations made, and the immediate results recorded at the time of the entry, without appended interpretation beyond the requirements of technical and operational control.